So the goal of this is to basically find your maximum distance away from a certain point, and it has to lie on the ellipse. I have a graph of the ellipse right here, and this is the main point we're looking at, or this is the point 1, 0. Okay. Now, if you just think of this logically without even stepping into any numbers or anything, you know, the point furthest away that's still on the ellipse, somewhere on this path, whether it's down here or up there, they're going to be up around this area, okay? So they're going to be very small. You're looking for an answer that's going to have a very small x value, very close to 0, like 0.05 or 0.1 or 0.2 or something. And the y is going to be around 8 or 9, between 8 and 9. So you can just look graphically, analyze the graph to kind of see the ballpark of the answer where you're looking at. So our answers are going to be small x values, I would say, where we have, you know, it might be 0.05 and plus or minus, you know, 8.5. You know, so we already know the ballpark of where we're looking at just from setting up the graph. Cool. So let's just rearrange this main equation. So we have 81 x squared plus y squared. And I'm not going to leave you with the answer, but I'll leave you with something. I kind of want to leave you with something close. So if we rearrange this, we basically will have y squared is equal to this, basically 81 times, what is it? 81 times 1 minus x squared. Because we subtract the x squared on this side over here. And then we just factor out the 81. So then we get y is going to be equal to plus or minus 9, and in this case we'll just keep it plus positive 9 times root 1 minus x squared. Okay, because we just took the whole square root of this. All right, so once we have that, we can kind of verify that, you know, the point 1, 0 does lie on the ellipse, because if x is plus or minus 1, y is 0. So that means that point's valid. So when we're looking for the furthest point away, when it comes to these lengths over here, we'll call this length L. Basically, if these lengths are not changing with respect to x or with respect to y significantly, then we can basically say that the lengths are maximized, because again, the definition of a derivative is essentially it's the change in a function with respect to one of its constituent variables, and when that change becomes infinitesimally small, or dl is infinitely small compared to dx, this means it's basically approaching 0. And you can do the same thing with dy. So we can go in two directions here. Now, what direction do I want to go in? Well, let's just first of all look here. So L, first of all, is going to be a vector, okay? So this is basically, we can call this vector L, okay? And we can say it is going to be some distance x away from 1, away from the point 1, 0, okay, in the x hat direction. And we're going to take a derivative of vectors because first of all, I feel like it's good to show people this, show different students in calculus this, and also just not just skip straight to scalars, because you're going to have to take derivatives of vectors in the future. And then it's going to be some point y away from 0 in the y hat direction. And these hats these are unit vectors, so the value or the magnitude of x hat and y hat are 1. So we can just say in parentheses here, x hat, the magnitude of x hat is really equal to 1. So when we take the derivative of 1, it's going to be 0, correct? Because we can see these hats as a constant. So what we can do is reduce this, and this will basically reduce down to x hat minus x hat plus y hat, correct? And then what we can do is you kind of I'll leave you to kind of do some of the intermediary steps, and when we take the derivative of this guy, we're basically going to be setting it to 0 because, again, if the change in length is insignificant compared to your change in x as you're going along these lines, that means you have by definition maximized the distances away from that point. But we still have to make sure it's on the ellipse. So how do we do that? We plug in the equation for the ellipse in one of these variables, which is y. So we can plug in this equation, 1, into here. Okay? Now when we do that, we plug that in, and then we take the derivative of all this and we set it to 0. So we can say d, the derivative of vector L with respect to x will eventually become sorry, I just need to look at this right here. 1 minus 9x over square root, I'm just looking at my notes here, 1 minus x squared, okay? And of course we set this equal to 0. And then what happens is let's just do a little bit of math here. We'll get 9x is going to equal the square root of 1 minus x squared. Square both sides. And we'll get 81x squared is going to be equal to 1 minus x squared. And that leaves us with 82x squared is equal to 1. So x squared is equal to 1 over 82. And then x is equal to plus or minus the square root of 1 over 82. All right. And yeah, so it should be, I'm getting x is equal to plus or minus 0.11. And is this logical? Does this make sense? Yeah, it's close to 0. In the points that will be furthest away from this point that are still on the ellipse it's gonna be somewhere around here. I would say it's probably in the negative range because the negative range is further away from here, but it could be either or, really. So let's go down. So just to the next one, what we can do is we can just take our original equation, which was 81x squared plus y squared equals 81. And we can just leave the x in the 1 over 82 format, square root of 1 over 82, right? Yeah, it's the square root of 1 over 82. So if we go 81 times 1 over 82 to the 1/2, sorry, squared plus y squared equals 81. We will essentially have this 2 will come here, and then it'll be 81 over 82 plus y squared equals 81. And essentially, you'll get your y squared is going to be This is 81 minus like point. Let's just do this. So 81 minus that is going to be 80.012. So y is going to be equal to, you take the square root of both sides, and then y is going to be equal to 8.95, 8.94 gives some change, plus or minus. Now, it's really going to be up to you to decide, what we're going to do here. So we have 0.11, we have plus or minus 0.11 for x, and then plus or minus 8.95 for y. So, but does this make sense? Let's go back here. So 8.95, it's up here around 9. Yeah, it should be around here. But again, we plugged in either of these values. So I believe this should be free game right here. And that should be the answer. I mean, I didn't really mean to give away the answer. I kind of wanted you to work for it. But I think that should be good. All right.